Hey, in this video we'll be adding some features to the farm game. I'm going to add a buying menu so that we can actually get some animals on our farm. In the last video we had left off with setting up the structure for this whole thing, being able to store a bunch of grid objects and be able to get a visualization of that, and setting up a menu so that we can pick some options that do nothing. Okay, so first I'm going to have to add a menu option for buying. So let me find where that is. Game. Okay. I think I want 1 to mean buying, so let me adjust my menu. Okay. Alright, that seems good. Let me add another function for do buy. Alright, so now I can do all my buying stuff here. I'm gonna clear the screen. Let the user know what's going on. And then give them some options. Okay, how much is a cow going to cost? Money is arbitrary. I can call it whatever type of money I want, gold or dollars, and the values don't really matter, so I don't know. Let's make some cheap chickens. Not a pug. Alright, that's fine. And then maybe an option for none of them. Okay, now let's prompt the user. We got our nice prompt function that returns a string. Okay, so they say one of these things. Let's convert that string to an integer. Or we could just compare the string. That would work fine. If input is 1, then let's buy a cow, chicken, pig, and everything else. Well, I guess we'll explicitly handle going back so that you can repeat this menu. Okay, so back is easy. We can just return from this function. Cow, chicken, and pig. We're going to need to make first, we should check to see if the player has enough money. $1,000 for a cow. We didn't store money yet. There's a farm object. There's nothing that's storing money, so I'll just put an integer in here. What I could do is create like a player object, which would make a lot of sense, and then it could store all of the information about the stats of the player. And then the player would be responsible for like saving that to a file if you were saving your game, that sort of thing. And that would be great, a great responsibility for a player class. But I'm going to keep it a little bit simpler right now. So int money, when this all starts up, money, this integer, because it's a plain old data type, it's just an integer, is not going to be initialized. There's no constructor for it. So I'm going to have to write a constructor for the game object in order to initialize that. So let's say we start off with 2,000 money, enough to buy a couple of things. That seems good. Alright, now we can check if money is at least 1,000, and then we can buy a cow. This makes me think we should probably tell them how much money they have. Okay. Alright, you bought a cow. And just to be nice, let me subtract the money and then tell them how much money they have left. Cool. Now we want to add an animal. So let's create the cow, new cow. And of course I'm using pointers here. Dynamic allocation here on the heap because I want this cow to last outside this function. If I just did it on the stack, cow would be gone, we wouldn't have a new cow. And so I'll be able to store this pointer in any container that can store cows or anything that a cow pointer can be implicitly converted to. And pointers to classes can be implicitly converted into any of their base classes. So a cow pointer could be stored and pointed to by an animal pointer, or the same memory address could be stored in a grid object pointer as well. So I'm getting errors here, undefined cow, so that's because I have not included cow.h. This file needs to know about cows. Okay. So I created a new cow and I need to add that to the grid. So farm dot. And so I've got a grid object. It is 16 spots, but I don't know which one's open. So I'm going to have to just use a function, pass that off, and give that responsibility to the farm to add this this cow. There's a chance though that I might have bought too many animals and I can't fit a cow. So let me make sure. So if this should be here. Okay, check to see if there is space left in the farm. And do all of this if there is space. Otherwise, we can print out there is no space for a new cow. Right? And if we don't have enough money, we should also say something to that effect. Right? And once we've made all of this, told the user all that information, let's just wait for them to press enter. Okay, so we made a couple of functions here, assumed a couple of functions, has space left and add. So these are going to be similar functions. They both need to find an open space and use that. Let's see, farm. Alright, we're going to return true or false. Do we have space left? And I will have to go through all of my farm spaces. Let's see, it's a 4x4 grid, so I could reuse this loop. Get rid of the printing, because I just want to return true or false. I don't want to print anything else. So, now, I need to check if there's anything there. The nice thing about pointers is that they are a nullable type. They could store the value null, which means nothing's there, or they could point to a valid memory address. So I could check against that value null to say whether they're there or not. So this is, which way am I doing it? I don't think I specified. So let's just do X and Y, I guess. So column, row. If that's null, then we can return true. And then if we go through our entire grid and don't find anything that's null, then we'll return false. No spaces left. Okay, so let's put in the add function. You can add lots of things. So let's say you want to add any old grid object. This will work for animals, it'll work for cows, chickens, and pigs, because they are all inheriting from grid object. Alright, so let's go through the same process. If we have a null pointer, then we found a spot for it, and that's where we should add it. Okay, that spot is getting this object. And then once we've done that, we don't need any more, we're done. Otherwise, if it goes through and doesn't find a spot for some reason, it just does nothing. Nothing will happen. Okay, so now we're able to add objects to our farm. That looks pretty good. Let's fill in these other ones for chickens and pigs. I'll need to include those header files. Include chicken, include pig. Okay. So what's interesting here, when you start copying and pasting code, you'll notice similarities in your code. Necessarily, if you're copying and pasting, there's got to be something similar. So then I should start thinking about, well, what is different? Saying cow is different. Creating a cow object here is different. And that's the price is different, maybe, for a chicken. But if those are the only differences and all the structure of this is the same, this would make a great function instead of just duplicating the code. I could do a function call. So let's see if that makes sense. I think the toughest part is going to be the type parameterization. So this might be a good place to use a template. Yeah, let me try that out. So what I'd like to do, try by animal or object or something. I want to specify that it's going to be a chicken here, and then what is different? The cost is different, so chickens cost 10. The name is different, so let me put in a string chicken. And what else? Is that it? Type, name, yeah, cost. Alright, so now this is the function that I want to make. Try by object. It's going to take a type template parameter, chicken string, or a name string, and a cost. Okay, we can do that. And it's not going to return anything. Try by object. So I want it to take a type. So it needs to be a template. And then it's going to take a name and a cost. Price, whatever. Alright, now I can start using these parameters instead of the hard-coded values. Instead of cow here, let me break that up. And then instead of specifically a cow, there's going to be an object, and the type is T. There we go. No space for a new name. Not enough money for a new name. Right, that looks really nice. So assuming this works, that should work for any of these animals. Make that much nicer. Let's try buying a cow, chicken, and a pig. Cow is 1,000, pig is 100. Okay, great. So in a production game, even these hard-coded values are no-nos, like just putting 1,000, 10, 100. These are things that I would want to load from a file, like a settings file, or some resource that is built into my program, so that I don't have to leave it to the programmer to change these, and I can leave it to a designer instead. Okay, I think that will work. We want to make sure that this loop, or this does loop, while, yeah, we can just loop forever. And if the player ever chooses 4, then they get out of this loop, just by dropping out of the function. Okay, cool. That looks decent. I guess we ought to try it out. Let me see. We have money. We have a grid. We can go through the buying. What does not happen is visualizing this. So I don't really know. I guess I'll get this message. So let's look for that message. Let me make sure. Not a valid option. Then it's going to clear the screen. Let me put that in there. Okay. Alright, so we do need to buy an animal. Buy a cow. No space for a new cow. That's wrong. So let me look at what I did. Farm. We check for space left. For null pointers. The problem here is that just like any other plain old data, this is a pointer, a grid of pointers. It is not guaranteed that it's going to be initialized to null for each of these pointers. So I definitely need a constructor. This is going to be just garbage values that it's storing, random memory addresses essentially. It's going to be very unsafe to access those, as you can imagine. So let me initialize this memory. So what I could do, I could go through all of this with a loop, right? That would be nice. Okay, so that'll set all of it to null. But let me show you another way as well. Since I know that this is a solid block of memory, contiguous memory, there's a built-in function called memset. And memset takes in a destination pointer, a value that you're going to set it to, and set the stuff there to, and a size. And this works in terms of bytes. So this is only for working with blocks of memory. It doesn't care about what type of pointer you're working with. Notice it uses the void star type, which is like saying any type of pointer. It doesn't have a particular type, but we can assume that it works with bytes, and that also means that this value is we have to be careful with this value. The only value that really makes sense for us here is 0, and it'll zero out the entire block of memory that we're describing. And how that's useful for us is that a null pointer has exactly the value 0. So setting all of this grid, all of these pointers to 0, is going to make them all null. So this is an alternative way. So my destination is grid. It is a pointer. And the value 0. And the size is, there are 16 of these, times the size of an individual pointer. Alright, so pointers in x86 are going to be 32 bits. 16 times 32 bits, or 4 bytes. 16 times 4 is like 64. So it'll clear or set 64 bytes of memory to 0. And let's see if this goes through for us. Alright, yeah, I bought a cow. I have 1,000 left. 1,000 cows? I think that's a UX issue. I should put money in there. Dollars. Alright, this says I have $1,000. Okay, great. So that's working. Cool. Alright, let me go fix that. You have, yeah, it's in try by. Okay, units. Gotta remember units for those values. So, next I want to see that there actually are animals in my farm. When I draw this, I want to replace these spaces with the contents, some indication of the contents. So let's see if this grid location is null, then this is the right thing to print. But if it's not null, then I want to get its name. So let's print out accessing this object at that spot. It's a pointer, so let me dereference it and access one of its members. And grid objects, they don't have anything going on. So I might as well add something here. So I'm going to need the string class. I'm going to want my namespace. Alright, let's just give him a name. Yep. Print out their name. Actually, doing this as a function might be better. Let me say a virtual function called getName. That'll give me some more flexibility. It's also clear that I shouldn't be able to instantiate just a grid object, so this is a good candidate to make it pure virtual so that I don't have to implement it in this grid object class. Instead, I implement it in one of the sub-objects. Animals, they don't all have one name or one way to get their name, but these very specific animals, they do. All right, let me add this getName function and override it. Did I do that? Oh, I didn't do that for the other one, for speak. Override is technically an optional keyword in C++, to mean that you're overriding a virtual function's functionality. But it's a really good indicator for the compiler to help you catch problems. If you like slightly misspell something or don't capitalize it, it'll catch that out for you. Alright, let me add this to the other specific animals. Chicken, pig. Okay, that looks fine. Oh, let me add the overrides to those other ones too. Alright, so now back at the farm, we want to get name, print that out instead of these spaces. But look at these spaces, 1, 2, 3, 4, 5 spaces. And what if we print out chicken? That's going to be more than 5. It's going to really mess up our grid arrangement. So let me use a function of this string class. There's a substring function that lets me pick out a piece of this string, and I want to limit it so that it starts at 0, the 0th index, and has a maximum of how many? 1, 2, 3, 4, 5. Maximum of 5 letters. So then I kind of need to know how much filler, how much more spaces I need. So I think I need to put this into a variable. So I can also check the same string's length. Okay, so that's the substring. We want to print that out. And then for every character less than 5, we want to print out a space. So let's say I could do some math and calculate how many spaces I need, but I'll do it this way. Int I is s.length. I is less than 5. And each time I go through this, I'll print out a space. Ooh, okay. Hope that's it. Let me try it out. Okay, let's buy an animal. Let's get a chicken. Alright, let's get a pig. Let's get a cow. Let's go back, and I don't see anything different. Let's see what's going on. Oh, that's why I didn't expand my window. That's the problem with this console. I really hate it. Okay, actually it worked. So chick fits in there. It chopped it off at 5 characters. Pig fits in there. It chopped it off at 5 characters, but there's only 3. So it gave me a 3-character string. And for every character it was missing, to build it up to 5 characters, I added a space. Alright, works. Looks pretty good. Okay, so that is buying animals, manipulating some of these objects in this grid, and it's getting pretty far along. We can do some stuff in this game. So in the next video, let's add some more features. Let's add information about these animals that differentiates them, and things about animals that differentiate them from grid objects. And we'll see an important way to know what type you're dealing with during the runtime of your program. See you then.